from 0 to 1 of e to the negative kx. Oops, sorry. And then that ends up being negative 1 over k e to the negative kx from 0 to 1. Now, this comes from the chain rule. So if you imagine taking the derivative of e to the negative kx, we would end up with negative 1 over k, or we would end up with negative k right here. So we need something times negative k equals 1, which is the coefficient from the beginning, and that solution is going to be negative 1 over k. So that's where this comes from. It's like the backwards chain rule. You can also do this using u substitution. So your u would be negative kx. Your du is negative k dx. You want to, dx, I'm sorry. You want to replace your dx with everything du. And so, let's see. Oh, there's no coefficient in front of the e to the negative k. And so we want no coefficient right here, or a coefficient of 1, kind of like a silent coefficient. And so we have to multiply both sides by negative 1 over k in order to get that. So we get negative 1 over k du is equal to dx. And then this piece is the piece that we can sub in for the dx. So that's where that comes from. And then when we fill all this in, we would get negative 1 over k e to the negative k times 1 minus negative 1 over k e to the negative k times 0. Okay. And then this ends up being negative 1 over k. Anything to the 0 power becomes 1. So then this is going to end up being, what am I doing? Oh, white out. Negative 1 over k e to the negative k plus 1 over k. And then we can simplify this by factoring out a 1 over k. And we get negative e to the negative k plus 1. And what they asked you to do was solve for a specific form of this. And so all we do is rearrange so that the 1 comes first and then the negative e to the negative k comes second. So they wanted you to show that this indeed was the integral. So that's how we get there. Okay. Hopefully that made sense. That was part A. Part B, part 1 of B. Let's see. I have part 1 and part 2 marked a little bit weirdly. I know that both of these are in the problem. So they ask you to sub in, I think that's the second part. So the first thing that they ask you to do is to draw the integral from 0 to 1. Hold on. Okay, I'm not gonna guess. Let me just look at it. What number was this 10? Did I go too far? I did. I'm sorry. Let K be finds 0.5, sketch the graph, and then shade the region, and then find the area of the region. So sketch, shade, find the area. Where are we? I need this guy. Okay. Oh, and the camera. Okay, here we go. All right, so we first want to sketch. And I don't remember if this was calculator active or not, but all you really need to know is, I didn't make a table for this one. I made a table for the next part, I think. So if you sub in, let's see, our K is 0.5. So y is equal to e to the negative 0.5x. So all you need to know is that when you sub in 0, this whole thing becomes 1. Okay, and you can sub in a few others. So we had to label this point specifically. You also would get the point. So if this is 1, if this is 2, at 2 you get like 1 over e. And then at -1, you got negative, oh, I don't know where this really is, but it was like -1e to the 1/2. So you end up getting a curve that does something like this. If you can graph it, obviously, definitely graph it. I probably should be looking at which things are calculator active because that would cut down on a lot of time, I think. Anyways, so it wanted you to find the region here between the function, the x-axis, and then the line x equals 1, which is this dashed line I just drew in right there. So that's the guy right there. So that's part 1, part 2, and then part 3. So that's part 1. Part 2 was the shading, and then part 3 is actually solving the integral. So we have the integral from 0 to 1. I should have just like printed out my own copy of this review. I'm being nuts right now. From part A, we know what this integral is. We know that it's going to end up becoming this, and we know that k is 0.5. So we'll have 1 over 0.5 times 1 minus e to the negative 0.5. 1 over, this is a half, Claire, becomes 2. And then 1 minus e to the negative 0.5. And I don't remember how far it asks you to go out. You could also rewrite this as, oh, this is negative? No, it's not. Yeah, this is good. This also could be rewritten as 2 minus 2e to the negative 0.5, or if you did it as a decimal, 0.889 units squared. I feel like I made a mistake because it says it differently on my paper, but I think I might have written it down wrong on my paper. No, this is fine. This is fine. Okay. All right. So that's part or number 10. AB. And oh, we need C. C wasn't hard though, and because you didn't have to do parts 2 or 3. So for part C, it asks you to find dy dx in terms of k, where y is equal to e to the negative kx. This isn't so bad. Dy dx is just going to be negative k e to the negative k. Okay, there you go. That's it. All right, now number 11. It said to graph the function. I did a little chart. So I had -1, 0, 1, and 2. At -1, you got -1/3. At 0, you got -1, then 1, then 1/3. And I drew this graph in. So let's see here. We need 1, 2, -1. So at -1, we had like -1/3. Maybe this is 1 and +1. Okay. And then at +1, we had 1. At positive, that's not even correct. At +2, we had 1/3. At -1, we had -1/3. Did we already do that? Oh, and at 2, yeah, wait, we're missing one. -1, oh, at 0, it was at -1. So this means that there's basically 2 pieces to this function. There's a vertical asymptote somewhere, okay, somewhere between 0 and 1, and so this function is going to look like this. So it says find in terms of k. Oh, no, that's the last problem. So what I wanted you to do was to calculate the volume when you rotated this function from 1 out to some variable b. We don't know where b is, but let's like just choose one to look at. I drew this way too far out. This should really only go that far out. And then you can imagine taking this piece down to the x-axis and extending it out to like some b value and rotating it around. Man, my last picture was way better. Rotating it around the axis. This is something greater than 1. So it's something up here, and you'll end up with this cylindrical thing, maybe kind of like a trumpet almost. And then it wanted you to calculate the volume. Volume is always pi times the integral from 1 to a value. And then we have to square the function because remember the function acts like our radius and volume is pi r squared for a circle. And these are just disks stacked up on top of each other. The disks have different radii according to the x value. Okay, so this you shouldn't have a calculator for because you need to find it in terms of b. So we would have pi, and squaring a fraction means you just square the numerator and square the denominator. 1 squared is 1, so this is really just the integral from 1 to b of 1 over 2x minus 1 squared dx. So then we're going to add 1 to the power in the denominator. The power in the denominator, if you brought it up to the numerator, would be -2. Add 1 to get -1. So when we integrate, we should get pi times 2x minus 1 to the -1 power, but we need to use the chain rule. So I need -1/2 out here. Do I need that? Yeah, because if you took the derivative of this, the -1 would make this negative, and then we would multiply by this +2 to get 1 as our new coefficient out front. We are integrating this from 1 to b, so that's our little integral. And then I'm going to put my equal sign out here so I have some more space. And I'm going to pull this -1/2 out in front of the pi. Just so that I have it's less cluttered inside of here. And so then I would have, oh, I think I did this wrong on my paper. Oh, well, I'm doing it right now. I would have 2b minus 1 to the -1 power. That's what I missed on my paper. Minus, and then when I sub in 1, I get 2 minus 1, which is just 1 to the -1 power. Okay, so this ends up being -1/2 pi. And then 1 to the -1 is just 1. So this is 1 over 2b minus 1 minus 1. That's ugly, but whatever. Feel like I could probably make this prettier. Or we could just leave it. Let's just leave it. So if you got something like that, that's fine. I don't know exactly what the solution that I wrote out says, but we'll see. If you need help on like if this is different from the solution, also this is units cubed, then ask that on the discussion board for today and I'll fix it. This video is going to be so long. Okay, so that was number 11. All right. I'm really tempted just to post solutions for this because it's so fun. So now in exercise 5, you guys asked about 4, 5, 9, and 10. Okay. So 4, oh, there's some up here that are calculator active, so those will be nice. Okay, so number 4, it asks you to find the area of this function, and it gives you a picture, I'm pretty sure, but it doesn't tell you the top limit of integration. You know the bottom one is 0 because you see it intersects 0. So first we have to find that other limit. So we set 0 equal to x to the 4th minus 8x. Factor out an x. And then you have 2 separate factors that you can set equal to 0. So 0 equals x and 0 equals x cubed minus 8. This one's solved. When you add 8 to both sides and take the cube root, you should get that x is equal to +2. Okay, and that's the only solution. If you had -2 in there, you would end up with -8, and that doesn't work. So we have to go from 0 to 2, x to the 4th minus 8x dx, and this should be really straightforward to integrate. I have a feeling this one was calculator active, but I'll go ahead and write out the algebra that I did. When you sub 0 in, it just becomes 0. I didn't Oh, I skipped a step. Sorry. 1/5 x to the 5th minus